These are the 4.8 notes for PreCalc. We are going to be working with rational functions and finding their asymptotes. So our essential question, how do I find the asymptotes of rational functions? First, we need to talk about what a rational function is. What it is just two polynomials set one on top of the other. So it looks like a fraction. So for an example, I'm just making these numbers up. You could have like r of x equals, and oftentimes they'll use r for rational. So you just have a polynomial at the top and a polynomial at the bottom. So there are three different types of asymptote lines, and asymptote lines are where the graph never crosses or touches. You have a vertical asymptote line, which, let's say, I'm just going to make this up. I'm just going to put this right here. That would be a vertical asymptote line of x equals 2. It crosses through the x-axis, and it's crossing at 2. Horizontal and oblique are kind of in the same category. You have horizontal, where you can go straight across. That would be an example of y equals 1. And again, I'm just putting these lines wherever right now. I don't have a problem to look at, so I'm just showing you an example of a vertical and a horizontal. Now, when we talk about oblique, oblique is when you have a diagonal line. So oblique just means diagonal. And these are the ones where we have just y equals mx plus b, our traditional lines that we graph in algebra. So let's say you had a point here, and you were going up 1 and over 1, up 1 and over 1, up 1 over 1. This would be an oblique line. And that would be y equals, the slope would be 1, so 1x. And it starts at negative 1. So again, it's going to notice it's going to be in a more traditional form, y equals mx plus b. Okay, so first we're just going to focus on our vertical asymptotes in this first section. So notice just working on the vertical right now. In order to find a vertical asymptote, we need to set the denominator equal to 0. Set the denominator equal to 0, and you solve it out. So notice your directions, find the vertical asymptote. We are not talking about horizontal or oblique yet, just focusing on our vertical. All right, so example number 1 says r of x equals 5 over x plus 2. Because all I have to do is set the denominator equal to 0, the 5 is not going to matter for when I'm finding the vertical asymptote. It's going to come into play later when we actually start to graph it. But for now, for finding the vertical asymptote, I take my denominator, x plus 2, and I set it equal to 0. Subtract 2 from both sides. X equals negative 2. And so that I can keep things straight later when I'm doing all of this together, I usually write the letters VA in front to stand for vertical asymptote. So the vertical asymptote is x equals negative 2. Just so you can see, if I were to graph that, you would have it over here at negative 2, vertical line. Okay, so example number 2, I'm going to take my denominator, set it equal to 0. What do I do with the numerator? Nothing. You could ignore that for now. We'll use it later on. Add 25 to both sides. And then I can square root. When I square root a positive number, I get plus and minus 5. So this is actually 2 lines. One is at positive 5 and one is at negative 5. For problem number 3, notice each of these has a slightly different notation. One has a little r, one has an F, one has a capital R. Those don't really matter, just different ways of writing it. I'm going to take my denominator, set it equal to 0. Do nothing with the numerator. That's not important to us right now. Subtract 9 from both sides. Square root. When I square root, I get i's. Because I'm going to be graphing these things, I can't graph imaginary numbers because imaginary numbers do not exist on a graph. So what we're going to say is there is none. That just means there's no vertical asymptote. We'll still be able to graph it, there just won't be a vertical asymptote. So let's make a little note. No i's here. No i's are necessary here. Example number 4, take your denominator. Set it equal to 0. Ignore the numerators for right now. I'll make a little note of that too. This is a factoring problem. I have 3 terms. We call it a trinomial. And we are going to factor it. So a lot of you guys learned the X method for this. That's fine. Otherwise, you're looking for numbers that multiply to -10 and add up to make +3. That combination should be 5 and 2. And then just make sure your signs work in order to get you +3 and -10. It's going to have to be a +5 and a -2. It's the only combination of signs that will give you a +3 and a -10. Just like we did last unit, we're going to take what we have there, set it equal to 0, and solve. For most of us, that just means switching the sign. So x plus 5 becomes an answer of -5. And x minus 2 becomes an answer of x equals 2. And I'm going to keep the x equals here. That way it looks more like a line, as opposed to just having the numbers -5, and 2. All right, so that's how we find vertical asymptotes. On the back side, we're going to find the horizontal and the oblique. So we have a big chart here on the back because we have a lot of different categories that things can fall into. So how you do this is you've got 4 categories on the left. You've got the degrees, you've got low over high, same over same, high over low, and high over low plus. Then next to it, you have an example of what one of those looks like. In the middle, it tells you the type of asymptote. Horizontal asymptote means it's going to look just like that. OA oblique asymptote means it's going to be one of those diagonal lines. And then none obviously means you're not going to have any at all. And then at the end, it tells you actually how to find it. So let me just go through this chart with you, make sure we understand it. The degree, if you have a low degree, meaning the exponent, at the top and a higher degree at the bottom, for example, you have x to the first compared to x to the second. So you have a degree 1 over a degree 2. 1 is low, 2 is high. That gives you a horizontal asymptote, and your answer is always y equals 0. Regardless of what the numbers are, what the problem looks like, if you have a low over high, it's automatically y equals 0. Those are my favorite to do because they require the least amount of work. The next level here, we have the same over same, which means the same degree or exponent at the top and the bottom. Here, I notice I have a degree 2 and a degree 2. So the exponents are the same. Gives me a horizontal asymptote. What I do is I divide the coefficients, and the coefficients are these numbers in front. So this 2, and even though there's nothing there, we know it's an invisible 1. So I take 2 divided by 1, and that gets me 2. Because it's a horizontal line, write it as y equals 2. The next category is what we call high over low. Here we have a high exponent, degree 2, over a lower exponent, degree 1. This is going to give us an oblique asymptote. What I need to do for this one is long division. This is the one that's going to take a little bit longer. This is based on our video from yesterday. So we're going to need to take our, let me change colors here. Let me get the x plus 5 on the outside. And x squared plus 8x plus 12 on the inside. And then we're going to divide it the same way again we practiced yesterday. So I'm going to ask myself x times what gets me x squared. That would be x, put it at the top. Second step, multiply. X times x, x squared. X times 5, 5x. Change the signs. Cancel. That gives me 3x. And the last step, drop down the 12. Do the whole process again. X times what gives you 3x? That would be 3. Put plus 3 at the top. Multiply. 3 times x is 3x. 3 times 5 is 15. Step 3, subtract or change the signs. Cancel. And combine. Now, one thing about this, you actually don't want to use the remainder here. So we are going to ignore the remainder. We want our line to look like y equals mx plus b. And this right here, this x plus 3, looks very close to that. All I'm going to do is put a y equals in front. And there's my answer. If you put this negative 3 over the x plus 5, it's not going to look like a slope-intercept form. So we're actually going to ignore the remainder down at the bottom and just focus on the x plus 3. Those are my least favorite ones. You can probably tell why. They take a long time. All right, and we've got one more category here. This last one is called high over low plus. That's when your high degree, 4, is more than 1 degree away from your bottom one, degree 2. So that's if you have more than 1 degree difference. More than 1 degree difference. And this only applies for the high over low. There is no low over high plus. So you can have as much difference here on the degrees on the low over high as you want. So you could have a degree 1 and degree 7. That's still fine. It's only this high over low category that if you have a degree that's more than 1 off, the answer is none. That's another easy one to do. All right, let's see what we can do with these practice problems. Notice here, the directions are saying find the horizontal or oblique. That means we're just going to be using this table, this chart up here at the top, in order to find our answers. What we did on the front side is vertical asymptotes. That's a completely separate category. So when we start graphing these, we're going to have 3 steps. You're going to find the vertical. Then you use a chart to find the horizontal oblique. And then your third step would be to graph it. Okay, so find the horizontal or oblique asymptote, if any, so that means there might be none, of the graph in each rational function. So looking at example number 1, I need to just identify which category this falls into. At the top, I don't see any x's. That's a degree 0. At the bottom, I see x. That's a degree 1. That would be low over high. Low over high means there's a horizontal asymptote, and it's automatically y equals 0. Let's take a look at our chart. Make sure we see where we're getting that from. Low over high, horizontal asymptote, always y equals 0. So you have to use this chart every time to reference back for each problem. All right, so for the next one, identify the degrees. This is a degree 3 at the top. Notice that 3 right there. Compared to a degree 2. So that would be a high over low. It's not high over low plus because they're only separated by 1 degree. So degree 3 compared to degree 2. So what I need to do on this one, high over low, it's an oblique asymptote, which means I'll have a diagonal line and it's going to be long division. All right, so I'm going to set this up long division. I'm going to get rid of some of these here. X squared plus 3 divided by x to the third, 5x squared, 2x minus 1. I first ask myself x squared times what? Gets me x to the third. That would be x. Then I multiply. X times x squared, x to the third, x times 3, 3x. Now notice with a 3x, I want to line it up under this 2x, not with that 5x squared. I want to line up my like terms. Then we switch the signs. Switch it, switch it. Cancels. Bring down the 5x squared. Combine those to make negative 1x. And bring down the minus 1. Then I do the whole process again. X squared times what will give me 5x squared. That'll be 5. So I bring my positive 5 to the top. Now the good news on this problem is because I ignore the remainder, as soon as I get to this x plus 5, I can just put a y in front and be done. However, if you want to keep going, 5 times x squared, 5x squared. 5 times 3, 15. Change your signs. Negative 1x minus 16 is my remainder. But again, I ignore it. So as soon as you get this second number up there, that 5, you can actually stop. It'll help shorten the problems a little bit for you. That's going to be an oblique asymptote, which means it's just going to be a diagonal line. All right, example 3. I have x to the 5th minus 9 over 3x squared. So this is a degree 5 over a degree 2. Remember, degrees are looking at the exponents. All right, so I go to my chart and I decide what I have here. Let's see, a degree 5 over 2. 5 is going to be high, 2 is going to be low. And 5 and 2 are more than 1 degree difference. So this is going to end up being a high over low plus. Bring it down here. High over low plus means there's none. All right, take a moment and see if you can do the next 3. I'll give you a little bit of downtime, but feel free to pause the video, and then you can kind of check your work as we go. Okay, so here's all the answers. Let me talk through it with you in case you are stuck or confused. Example number 4, you have a low over high. By that, I mean the x to the first compared to x to the third. Every time for low over high, the answer is always y equals 0. No work required. Always y equals 0. For example number 5, s over s means same degree over the same degree. Each of these are x to the exponent of 1, 6x to the first, and 2x to the first. So what I do is I divide the coefficients, the very front number. 6 divided by 2 gives me 3, giving me an answer of y equals 3. On example number 6, this was high over low. It was a degree 2 x squared over degree 1 x. So I did the long division. This one actually was a little bit easier to do because I just had an x out front. And then I ignored the remainder at the end to get y equals 2x plus 7.